Alright, what's up YouTube? It's your boy Adam3221 here, coming at you guys with another thrilling biomechanics lecture today. We're introducing the scintillating topic of static equilibrium. I'm coming at you live today along with my boys Sahil67, Blake 4522, Jason 2323, and Luke 1521. So, concept. All of the external forces acting on a body must sum to zero. Important equations to note here are sum of forces in the x direction, 0. Sum of the forces in the y direction, 0. And sum of the moments, 0. The first example that we're going to do is going to be arm wrestling. So without further ado, let's get into it. Okay, so for the math on the arm wrestling example, first I'm going to get into the diagram, then I'm going to tell you guys the math behind it. So first thing we did, we simplified everything into a stick figure drawing. We took a few artistic liberties, but I'm sure you guys will still be entertained by the results of this. So we start with the shoulders up here, clearly denoted by an S. Move to the elbow right here, which is an E, and then come together in the middle right there for what's an H. So first thing to note, sum of the forces in the x directions equals 0. So we have our coordinate plane labeled right here. Up is the positive y, that way is the positive x. So our first term right here, we've got rx1 pushing in the positive x direction, and we have rx2 pushing in the negative x direction here. So we're actually going to subtract rx2 from rx1 for the first term. Second term, we need the x values for the force of the biceps right here. So we have FBX2, which is pushing in the positive x direction, and we're going to add FBX1, which is pushing in the negative x direction, so that's why we have the negative sign here. Moving on to the stuff in the y direction, this is also going to be equal to 0, so we have FBY1 plus FBY2. These are both positive because they're both pulling up right here, and then we're going to subtract RY1 and RY2 right here because they're both going straight down. Last thing to note, moments right here also equal to 0, so all forces are equal and opposite, which we will show you right now when our subjects arm wrestle. Okay, so for our first demonstration, we're going to have Blake and Sahil demonstrate an equal and opposite force arm wrestle. Notice the passionate stare into each other's eyes as the lovers hold hands. Now, moving on to our next example, we have unequal forces. We have Luke here slamming Jason's hand into the table repeatedly.
Stop! What's up, y'all? I'm Blake. So we were in static equilibrium because the forces in the x direction were equal to 0.
Hi, I'm Sahil, and our forces in the y direction were also equal to 0.
Therefore, they were equal and opposite, and we were in static equilibrium.
We're not moving.
Hey guys, I'm Jason. Unfortunately, I kept getting beat because Luke was putting out much more force than I was. We were not equal and opposite in forces.
And then just a little disclaimer, because we went above and beyond, we put a 2D representation of a 3D situation. Just, you know, the forces, the general gist is that the forces are equal and opposite in static equilibrium and not in dynamic equilibrium. So.